In this video, we are going to solve example on unilateral Laplace transform. So first of all, write the equation for unilateral Laplace transform, which is given as x of s equal to integration from 0 to infinity x of t e raised to minus st dt. Now substitute the value of x of t in this equation. So integration 0 to infinity x of t is given as e raised to minus 2 t plus 1 u of t plus 1 into e raised to minus st dt. Now in above equation we have u of t plus 1. So here we have u of t plus 1. So this signal is shifted version of unit step. So if we plot this u of t plus 1 signal, so as it is u of t plus 1, it starts at minus 1 and it goes towards positive infinity with amplitude 1. So here we can say that u of t plus 1 is equal to 1 for t greater than or equal to minus 1 and 0 for t less than minus 1. So let us substitute this value. So whenever we are going to substitute this value, here the unit step signal, this u of t signal, starts at minus 1 and ends to positive infinity. But if we look at the limits of integration, the limits, lower limit starts at 0. So we cannot go beyond 0. Therefore, the lower limit starts at 0 itself. It doesn't go beyond 0. Though our unit step signal starts at minus 1, but we have the integration limit 0. So we cannot go below 0. And upper limit is infinity. The unit step signal is approaching towards infinity. E raised to minus 2 t plus 1 as it is, u of t, amplitude is 1, e raised to minus st dt. Now let us simplify this equation. E raised to minus 2t, e raised to minus 2, e raised to minus st dt. Now this e raised to minus 2 is a constant which can be taken out of integration. So e raised to minus 2, integration 0 to infinity. Now let us take these two terms together, e raised to minus 2t and e raised to minus st. Now remember here, whenever you have Laplace transform and if the limits of integration are from 0 to infinity, means if you have positive infinity value in your integration, always take e raised to minus sign common. And whenever you have integration of this kind, integration from minus infinity to 0, so if you have minus infinity term in the limits of integration, in that case take e to the power plus term common. So always follow this rule. So in our case, here we have the limits 0 to infinity. So it is plus infinity. So we have to take negative sign common. So e raised to minus, from the first term e raised to minus 2t, we can take 2 common, minus s. So minus is already taken common. So 2 plus s into t dt. So let us take its integration now. E raised to minus 2 plus s t upon minus of 2 plus s with the limits 0 to infinity. So now let us substitute upper limit and lower limit. So upper limit is infinity. So e raised to minus 2 plus s into infinity minus e raised to minus 2 plus s into 0 whole divided by minus of 2 plus s. Now at this stage itself we need to find out ROC. So the term e raised to minus 2 plus s into infinity, so it is e raised to minus infinity, but this term remains e raised to minus infinity until and unless 2 plus s is greater than 0. Therefore, we get the condition of ROC as 2 plus s should be greater than 0. Similarly, if you look at the second term, e raised to minus 2 plus s into 0. So if you multiply anything with 0, it is 0, and e raised to 0 is 1. So let us simplify it further now. E raised to minus 2, first term e raised to minus infinity is 0, minus e raised to 0 is 1, whole divided by minus of 2 plus s. So the final answer will be, so here minus, see 0 can be neglected, so minus minus will become plus. So it will be simply e raised to minus 2 divided by s plus 2. This will be your unilateral Laplace transform with ROC s plus 2 greater than 0, which simplifies to s greater than 0, that is not 0, s greater than minus 2, that is sigma greater than minus 2. So this will be your ROC. So in this way we can solve the example on unilateral Laplace transform. So you need to only remember that whenever it is unilateral, the lower limit of this Laplace basis function, the integration starts at 0 and approaches towards positive infinity. You cannot go below 0 in the integration. Just remember this thing into mind and then solve the rest of numerical the way we have solved it for bilateral Laplace transform.